Okay, welcome back. This is our lesson on phase shift. Now we've already discussed amplitude and period, and so the objectives of this lesson are going to be to consider the equations in the form of y equals a sine of bx plus c, so c is our new piece here, okay, and also y equals a cosine bx plus c. Now this c is going to be known as what we want to call phase shift, and it's going to obviously shift being in the name, it's going to be shifting our graph in a certain way that we're going to look at in this. And we're going to investigate how phase shift affects the graph of a function in this lesson. Okay, so when we move down here, what does it look like? Well, it looks like this. Okay, this c is going to tell us what we want. And so when we look at this graph, it's y equals sine of x plus pi over 2. And they're going to give us some certain stipulations here. We're going to go from negative pi over 2 to 3 pi over 2. Now, as I've been trying to relate to you, it's all about picking the values, guys. Okay, so obviously, because they told us to, we are going to start with negative pi over 2. Now, when we do this function, we're going to put in this value for x. Now, this is going to equal sine of 0, which we know is 0. So our x and y is going to be negative pi over 2, comma 0. Okay, it's that simple. Now, part of being a smart math student is recognizing this pattern and seeing what it is that they want us to do. Obviously, they started at negative pi over 2. We are going in increments of pi over 2. So a smart decision for me might be to say, let's keep going with these pi over 2 increments. So if I move up just a pi over 2, I get to 0. So I get y equals sine of pi over 2 plus 0. Or actually it'd be 0 plus pi over 2, but commutative property. Okay, so we've got y equals sine of pi over 2. And we know that that gives us 1. So our next point is going to be 0, 1. Getting these values from the unit circle again, guys. Okay, and so I'm going to move up again by an increment of pi over 2. Y equals sine of pi over 2 plus pi over 2 is equal to sine of pi. Looking on our unit circle once again, we get 0. So our next point is going to be pi over 2, comma 0. Move up by another factor of pi over 2. We get to pi. And we get y is equal to sine of pi plus pi over 2 is equal to sine of 3 pi over 2, which gives us negative 1. Now, it may be tempting to say, oh, is this ever going to end? It is going to end because we're almost there. So our last value is 3 pi over 2. And we get y is equal to sine of 3 pi over 2 plus pi over 2 equals sine of 2 pi, which we know gives us 0. So we have 3 pi over 2, comma 0. Now, 1, 2, 3, 4, 5. There's those 5 points again, guys. That's what we need. We need 5 points. And so when I'm graphing this, I'm going to go down just a little bit here. And I'm going to get set to start my graph. And so what I'm going to do first is I'm going to take my increments and put them on here. So they wanted to start at negative pi over 2. That's cool. We can do that. Obviously 0. And pi over 2. We get to pi. And our final increment is 3 pi over 2. Now, where are we on the continuum? If we scroll back up a little bit, we know that at negative pi over 2, we're at 0. So we'll just plot that right on here. No problems. Then we get to, at 0, we're at 1. And so I'm going to put my 1 on here. We can go there. That's good. At pi over 2, we're at 0 again. So at pi, we're at negative 1, so I'll put my negative 1 on here. Plot that, and then we get back to 0. There's my 5 points. it should come as no surprise to you that this is a familiar looking curve. It's the sine curve, yes? It goes like an S. It starts at our midpoint here, goes to a high point, goes back to 0, low point, 0. Now, this shouldn't surprise you because we understand that all of these are variations of the same graph. And so if we look at what the equation was, we see that we have this plus pi over 2. Now, obviously we moved back pi over 2, so we're going to continue to investigate a little bit and see if that is always true. This is going to be a little bit more difficult because we're going to have some different things going on. So let's be smart. We know that if we've got this 2 here, something is going to be affected by a factor of 2. Well, they've kind of helped us out here, and they've said go from negative pi over 4. So let's just start there. So negative pi over 4. Now, this is going to be y equals 3 times sine of 2 times pi over 4 plus pi over 2. Stay with me here, guys. Y equals 3 times the sine of 2 times a fourth would be a half, so that's pi over 2 plus pi over 2. So this is going to be 3 sine of pi, which is going to give us 3 times 0, which is going to be 0. So my first point is negative pi over 4, comma 0. Okay? We're not always going to do this, but when we do it, we need to be thorough with our work. Now, it looks like we're going to be going up in increments of pi over 4, so let's go to 0. So y equals 3 sine of 2 times 0 plus pi over 2. So this is going to be 3 sine of 0 plus pi over 2, so pi over 2. And when I do the sine of pi over 2, I get 3 times 1, which is 3. So my next point is 0, comma 3. We continue on, moving in increments of pi over 4, not 2, 4. So I've got y equals 3 times the sine of 2 times pi over 4. I think I made a boo-boo there, guys. This should be, up here, this should be negative pi over 4. So this is negative pi over 2 plus pi over 2. So this should be the sine of 0. Sorry about that, guys. Made a little bit of a boo-boo. We're back on track now because this one is going to be pi over 2. So we've got y equals 3 sine of pi. You should have told me, guys. The sine of pi still equals 0. So we're still good, but just a little bit of a correction there. Okay? Moving right along. Pi over 4, we're going up another pi over 4, so we'll do pi over 2. Y equals 3 sine of pi over 2 times 2 plus pi over 2, which is going to give us 2 pi's over 2 plus another one is 3 pi's over 2. So we're going to be at pi over 2, negative 3 because this is negative 1. So 3 times negative 1. I got to scroll down. I'm out of room. We move up one more pi over 4. And luckily this is the end of our interval. You see? We're at the end of our interval. Notice, how many points do we have? 1, 2, 3, 4, 5. Kind of saw that one coming. So 3 times sine of, I know it's tedious, guys, but stick with me. It's going to be worth it in the end. Now, a little bit more complex fraction here. Let's see what we've got. 2 times 3 pi over 4. So these 2's are going to cancel, so I'll have 3 pi over 2 because this will go to a 2, this will go to a 1. 3 pi over 2 plus pi over 2. And luckily, it ends up all right for us because 3 pi over 2 plus pi over 2 is going to be 2 pi. And we know that that's going to give us 0 because 2 pi is 0. 3 times 0 is 0. 3 pi over 4, comma, 0. Now, got my 5 points. Whew. I'm exhausted. I know that you are too. Okay, so our first point was negative pi over 4, remember? So when we did this, our first point up here was negative pi over 4, and we were at 0. So we're going to go in increments of pi over 4. Okay, so now I've got my pi over 4, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4. I have them all. Now, knowing that this is a sine graph, I'm going to kind of be able to see kind of where this is going to go. So we start out at 0. Okay? When I'm at 0, I'm at 3. So I'll mark off my 3. And I'm at 0, 3. When I'm at pi over 4, I'm at 0. So here's pi over 4. I'm at 0. At pi over 2, I'm at negative 3. Now when I'm at 3 pi over 4, I'm back at 0. It makes sense, guys. It's a system. It's a pattern. Because sine always starts in the middle, goes high, goes low, goes back to the middle. Now, let's look at how this is affected. The phase shift was negative pi over 4, right? We're back pi over 4. Well, if we take pi over 2, we're going back pi over 2, but we're dividing that in half, so by this factor of 2 here. And so here's a generalized piece of how we do this. The summary for this is going to look like this. Amplitude is going to stay the same. It's going to be the absolute value of A. Okay? The period we know is 2 pi over B. Okay? The phase shift is going to be the negative coefficient C divided by B. Look at this. In this equation here. Negative C, so negative pi over 2, divided by 2 is going to be equal to negative pi over 4. Negative C over B. Did it work out? Yes, we went back pi over 4. That was our phase shift. And so in general, this is what it's going to look like. Here's the summary. Know this. You need to know this. Okay? So now when I go down here, notice I'm going to say graph the following equations, but I'm not giving you anything of a table because I'm assuming that you are going to do something like this. Amplitude. Once again, I feel like we're comfortable enough now I can abbreviate a little bit. Amplitude is 2. Period is here. Is going to be 2 pi over B, which is 3. Okay? That's my period now. And so when I go to phase shift, it is going to be negative C over B, which is going to be negative pi over 3. Cool. So phase shift and period have the same denominator, which is good for us because that means that we're going to be moving this in a way that we understand. Okay, so let's look. This means that when we shift back, pi over 3 is going to be our target value here. Okay? And we're still going to need 5 points. And so let me relate this to you. If we know that the period is 2 pi over 3, 1 pi over 3 is going to get us to 0. Another pi over 3 is going to give us our 2 pi over 3. We have a third of a pi here and a third of a pi here. That's 2 pi's over 3. Now, we have the beginning and the end points. Here's the middle point. So we are going to need to get 1, 2, 3. We're going to need to get 2 more points. Now, halfway between negative pi over 3 and 0 is going to be negative pi over 6. Halfway here is going to be pi over 6. And I'm going to graph by doing this. It's still sine. It's going up to 2. And it's going down to negative 2. And I know that's going to start at the 0 here. Okay? Where's it going to go first? Well, it's going to go up first. Then it's going to cross. Then it's going to go negative. Then it's going to cross again. Here I am. How awesome is that? Because if I can find the beginning and the end, all I got to do is split it down the middle. Anytime you have a numerator of 2, you're good, because that means that you're going to your phase shift and then the same absolute value on the other side. I think we need to do another one. Stay with me on this one. Okay, so let's look at this next example here, and I want you to not be discouraged when you're doing these. It takes a while to get it down, but the process is always the same. Okay, so let's outline what we've got. We're looking at amplitude. Once again, we're comfortable here. We're using abbreviations, so the amplitude is going to be the absolute value of -4, which is 4. The period is going to be 2 pi over b, which is going to be 2 pi over 2. So my period is pi, that's good. And my phase shift is going to be -c over b. So -c would be a negative 3 pi over 2 over 2, which is actually going to give me something like this. If I divide this, it's going to be a positive 3 pi over 2 because it's negative, and divide it in half, so it's going to be 3 pi over 4. Now, how do I use this information? I know that my phase shift is going to take me to the right because my phase shift is positive after I outlined that. And so I'm just going to start here at 3 pi over 4. Now, I know that my period is going to be pi, so let's think about this. If I go 1 pi over 4, I get 2 pi. If I go another pi over 4, I get 5 pi over 4. If I go another pi, so I have 1/4, 2/4, 3/4 of the way that I'm going. So it's going to be 6 pi over 4, so it's going to be 3 pi over 2. And this one is going to be 7 pi over 4. It's a counting game, guys. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4. Now, that's my phase shift. So I'm starting here. And if I'm starting there, and I know that my amplitude is going to be 4, so I know my maximums and minimums are going to be exaggerated in this way. So they're going to be up this way. My period is pi, which I have outlined here. And so what I'm going to do is I'm going to graph this initial. Remember, this is a negative here, so remember what that does. I'm going to graph the positive one first. I know that cosine starts at the top. This is cosine. Pay attention to that. It starts up at the top. So it's going to start at a maximum here, cross, go negative, come back up and cross, and go back positive. So here's what my graph would look like if it were not negative. Okay? And what I'm going to do is I am going to flip everything over using red. Okay? So this positive goes down and becomes negative. This negative goes up and becomes positive. This positive goes down and becomes negative. And these two guys, because they're 0, they stay the same. Here's what my graph looks like. Let me see if I can connect these dots. Okay, that's my graph. All I'm doing is following the simple steps, outlining amplitude, outlining period, outlining my phase shift, taking into account my negatives, and knowing about sine and cosine. It seems like a lot, I know, guys, but stick with it. Stay right there. You can do this. Thanks for watching.